Hi everyone, so today we're looking at Algebra 1, Chapter 7, Section 1, and we're focusing on systems of inequalities, which are very similar to systems of linear equations, but instead of having an equal sign, we're going to have an inequality symbol, which is a greater than or less than symbol. So we're going to find kind of a range of solutions rather than just a single point being a solution. So our learning target says I can write and graph an inequality to be able to interpret the solutions mathematically and contextually. So we're going to work our way through an example. It's a little bit of a longer one, but I want you to kind of recognize the difference between the solutions of a system of regular equations as opposed to an inequality. So this is problem number 1. It says cranking it up for the playoffs. And the story says Coach Purvis is analyzing the scoring patterns of a few players on the basketball team. So as they're getting ready for the playoffs, the coach is trying to figure out who are his top scorers. And he realizes that Bana has been averaging about 20 points per game between 2 and 3 point shots, or from scoring on 2 point and 3 point shots. So if you play basketball, you know that you can earn a 2 point shot or you can earn a 3 point shot from being outside that large 3 point circle, right? So we're going to look at kind of the combination of those shots and how that works for our inequality. So part A says if she scores 6 2 point shots and 2 3 point shots, will Bana meet her points per game average? So if I'm going to solve that equation, I would say if she scores 6 2 point shots, it's 6 times 2. Is equal to 12. If she scores 2 3 point shots, 2 times 3 is equal to 6. So the total number of points she's earned is 18. But that does not meet her average total points. Part B says if she scores 7 2 point shots and 4 3 point shots, will she meet her average? So again, I'm going to calculate doing 7 times 2 equals 14. And then also 4 times 3 is equal to 12. 14 plus 12 gives me 26. So yeah, in this instance, she would exceed her average. And then we'll do one more quick example, letter C. If she scores 7 2 point shots and 2 3 point shots, 7 times 2 is 14. 2 times 3 is 6. 14 plus 6 equals 20. So in that case, she meets her average. Number 2 says write an equation to represent the number of 2 point shots and the number of 3 point shots that total 20 points. When X represents the 2 point shots and Y represents the 3 point shots, 2 times the number of 2 point shots plus 3 times the number of 3 point shots is going to give me 20 total points. And we're going to take a minute and graph that equation. So I'm going to set up my graph. Presumably, I can reach 20 points by scoring 10 2 point shots So I'm just going to label my axis for the 3-point shots and the 2-point shots with a scale of 1, just going up to 10. And then I'm going to manipulate my equation so that it's in slope-intercept form, because I like it that way so I can graph it. Y equals negative 2/3 x plus 6 and 2/3. So 6 and 2/3 would be my y-intercept. My slope is negative 2, so down 2, and over 3 units to the right. I do that twice, connect my line, and I can actually go all the way down to 0, because if I score 10 2-point shots and 0 3-point shots, I did get a total of 20 points. So that's a pretty accurate graph. I'm flipping to my next page for my notes now, so I ran out of room. Number 4, the coach says Beta must score 20 points per game in order for them to win the playoffs. So if she has to score 20 points, that means she has to score greater than or equal to 20 points. So part A says, how can we rewrite our equation to reflect this situation? So our equation needs to change from having an equal sign to having a greater than or equal to inequality. So that's the inequality symbol, that little caret with the line underneath. That means greater than or equal to. There are 4 types of linear inequalities. They appear in standard form, which is ax plus by equals c. But again, instead of having that equal sign, we have a greater than, less than, or greater than or equal to, and less than or equal to. So those are the 4 options that we have for inequalities. Number 5 gives us this table of values. If she scores 2-point shots and 3-point shots and the total number of points she scores, we're just going to kind of list these potential combinations of shots. Now these were provided by the book, so I'm just giving you the table. And then the question asks us to place the data on the graph so that if the total number of points scored is less than 20, then we put an X on that coordinate. And if it's greater than or equal to, we put a dot on that coordinate. So I'm going back to my graph, and I'm going to mark those coordinates from my table: 2, 1, 6, 1, 7, 1, 8, 2, 6, 4, and 9, 5. And if it was less than 20 points, I put an X. If it was greater than 20 points, I put a dot. Question number 7 says, what do we notice? Well, we notice that if the coordinate appears above the linear form of the equation, then it is a solution to the equation. It's greater than or equal to 20. But underneath that line, it's an X, so it's not a solution to the equation. The combination of points do not add up to 20. Number 8, how can we interpret solutions of inequalities? And this is just our description. Points above the graph show greater than 20. Points below the graph show less than 20 scored. Now we just want to go back and make observations from our graph. And we're going to do that by shading the side of the graph that contains solutions to the inequality. So I'm going to take my highlighter, and basically any solution that appears above the line will be a solution to my inequality. And then I just want to think about the solutions of the linear equation compared to the inequality. Because the linear equation, the solution is going to be on the line, whereas the inequality is on or above the line, because it could also be greater than 20 points scored.